All right, this video is about adding or subtracting rational functions. So rational functions or expressions, I should say. So, before we get into this, rational functions are fractional functions. So I'm going to remind you how to add fractions. Let's suppose that we have x squared over. Let's just do numbers. Let's suppose we have 1 over 4 plus 2 over 4. When these have a common denominator, we are ready to add. So we keep the same denominator and we combine the numerator. So this could be 3 over 4. You have to have a common denominator. If we were subtracting, then this would be, you have to have a common denominator, combine the numerators, 1 minus 2, we would get negative 1/4. But if we have something like 3/5 plus 2/4, these are not the same denominator. We'd have to find a common denominator. The lowest common one here would be 20. So we'd have to change both of these to be 20. We have to do that legally. How we're allowed to do that is multiply this by the number 1. So you ask yourself, 5 times what gives me 20? 5 times 4 gives me 20. But I'm only can multiply by the number 1, so I have to also multiply 3 by 4. I have to multiply the numerator and the denominator by 4 because 4 divided by 4 is a 1. So my new numerator would be 12. What's going to happen here, I have to change this to be 20. I'd have to multiply this by 5 and multiply this by 5 again so that I'm multiplying by 1. My new numerator here would be 10. And at this point I could combine 22 over 20. And then if I can simplify that, which I can, I'll try to do that. I can divide 2 into both of these and get 11 over 10. And that would be my simplified fraction. So that's a reminder about how to add and subtract fractions before we get into this. All right, number 1. We are asked to add these two rational expressions. 5x squared plus 4x over x minus 1 minus 6x plus 3 over x minus 1. Here is something that we need to remember. And sometimes teachers, including myself, for sure, do not talk about this enough. And that is that every numerator and every denominator is a grouping. It is like it's got parentheses around it. It's grouped. So that means this minus right here, when we go to combine these, it will distribute to each term. Let's look at this denominator is x minus 1. This denominator is also x minus 1. They have a common denominator. They're ready to be combined. So when we combine this, we'll have x minus 1 as our denominator. The numerator will be 5x squared plus 4x, but this negative will get distributed to both terms, minus 6x minus 3. Gives us 5x squared minus 2x minus 3 over x minus 1. And I think this will factor. Let me just see. Negative 15, negative 2, negative 5, and 3. This times this is this, this plus this is this. This will factor, so I'm going to use the AC method to factor this. To factor, down here I'll factor it. 5x squared minus 2x minus 3. Rewrite the middle term into what you found it needs to be. 5x squared, copy him down. Rewrite negative 2x into minus 5x plus 3x. This plus this is this. Copy down the last term. Then you just group the first two terms and the second two terms. The greatest common factor here is 5x. Leaving me with the x minus 1. The greatest thing I can pull out here is a 3, leaving me with the x minus 1. So this is going to factor to 5x plus 3 times x minus 1. That is the AC method. Anyway, this factors into this. Let's see. So this can be rewritten into 5x plus 3 times x minus 1 over x minus 1. Now I see I have a common thing I can cancel out. Those are going to become 1s. This simplifies down to 5x plus 3. All right, that is simplifying that fraction. Right here, we have a common denominator of x plus 7. So let's go ahead and see what we can do with this. We can combine the numerators, but remember, this is a grouping, so that negative will distribute. We get x squared plus 9x minus 4x, minus 14 all over x plus 7. This becomes x squared plus 5x minus 14 over x plus 7. Can I factor that? I'm going to try. Let's see, I need negative 14, two things to add up to be 5, a negative and a negative. Oh, no. A negative and a positive is how I'm going to get a negative 14. So let's see. How about a 7 times negative 2? This times this is negative 14. 7 minus 2 is 5. So this will be x plus 7, x minus 2 over x plus 7. And we find that those will cancel, and we just have x minus 2 right there. Okay, so that is with common denominators. Let's see what they ask us to do in number 3. Number 3, they ask us to add these two rational expressions together, but they do not have a common denominator. So that's an issue. So let's create the lowest common denominator. The lowest common denominator for this is going to be something that contains both of these denominators. So I'm going to need a y squared times a 2y plus 1. This right here is going to be lowest common denominator. How you see if it's a good one, is this a good one? You ask yourself, can y squared divide into this? And it can. It would divide into that right there. Separately, can 2y plus 1 divide into this? And it can. So this is a good one. That's what I'm going to try to make both of these look like. So down here, I'm going to say, let's change this guy instead of y squared. Let's change it into y squared times 2y plus 1. And let's change this instead of 2y plus 1 into y squared times 2y plus 1. Okay? We can do that, but we have to do it legally. What changed here? This went from y squared to y squared times 2y plus 1. We multiply this by 2y plus 1. That means we have to multiply the numerator by 2y plus 1. What changed here? We went from 2y plus 1 to y squared times 2y plus 1. So we have to multiply the numerator y also by y squared. Now they have a common denominator, y squared times 2y plus 1. And we can combine the numerators. I'll distribute as I go. I have 5 times 2y is a 10y. 5 times 1 is a 5 plus y to the third. I can't factor that, so this is going to be my final answer. That's a combined fraction. All right, let's look at number 4. This denominator is y minus 4. This one's 4 minus y. These are almost the same. So when they're just different by a factor of -1, you just pick one that you want it to be, either this one or that one. I'm just going to choose this one. I'm going to make both of these denominators look like y minus 4. All right, right here, this one looks like y minus 4. I haven't changed anything, so don't mess with the numerator. Leave it exactly the same. Right here, I changed 4 minus y to y minus 4. How did I do that? I multiplied this by a -1, so I have to multiply the numerator by a -1. That means this is going to become a -20. So I have 15 minus 20, which is a -5 over y minus 4. That's what that one's going to be. Over here, we have a 6 and a 2. What's going to be the lowest common denominator? A 6 is going to be the lowest common denominator. So 6 and a 6. How did I make this a 6? It was a 6. I didn't change anything. Don't change the numerator. How did I make a 2 become a 6? I multiplied it by a 3. So multiply the numerator by a 3. This becomes 33x squared. Let's combine same denominator 6. These are not like terms, so you just write them together. That is going to be your answer to that. I'm going to do one more that will illustrate how to find a common denominator. So sometimes you can have one that's, you have to factor a little bit. So let me just make a little space right here, and let me choose a good one. How about, this is a good one. Let's see. we've got this right here. We have to combine 1 over x plus y. 1 over x plus y minus y over x squared minus y squared. Okay, let's do this one. Well, it's hard for me to kind of see what is in the denominator unless I factor it first. So I'm going to factor this guy. He's difference of squares. So this is the same thing as x plus y times x minus y. Okay. So now I got to try to come up with the lowest common denominator, something that both of these individually could divide into. This is what I think it would be. This one, x plus y times x minus y. And how you say, is this a good one? You say, can x plus y times x minus y divide into that? Yes, it can, separately. Can x plus y divide into that? Yes, it can. And I'd have an x minus y left over. So this is what I'm going to change everybody into. X plus y, x minus y is my denominator. And I did not change the denominator, so I do not change the numerator. Right here, I'm going to go from x plus y to x plus y times x minus y. What changed here? I have an x minus y. That means I have to multiply the numerator also by x minus y. 1 times x minus y is what I get there. Now I have the same denominator. Now I can combine. I have x minus y minus y these are like terms that can be combined, so this turns into x minus 2y over x plus y times x minus y. Okay, that's that one. Okay, I think that's going to do it.